Yes. George, are you okay there?
Yes, I'm here. I can hear you.
Is that a
It's
thumbs up?
on
Okay,
my
yeah,
monitor.
Okay.
approved. Rock and roll.
Rock and roll. Okay. Good evening. So I'm George Mendoza from Nara Labs. I've been with Nara Labs for 2 months. Been doing Rails since 2008. For this, yeah, for this talk, I'll be showing the lessons I've learned writing tests in spec style, which is more commonly used with RSpec. But for this talk, I'll be using Minitest because that's the gem that we're using with Nara Labs. In particular, I'll be using a gem called Minitest Spec Rails, which integrates the spec style API from Minitest with Rails. So I think we can just go ahead and I'll be doing a live demo. For this talk, what I'll do is demonstrate how I'm writing tests using that spec style. We'll be working on a simple task model, and in particular, we'll be interested with the due at field of this task model. This due at determines if the task will be due. So for this demo, what I'll do is we'll test drive a particular feature concerning that due model, due field. What we'll do is we'll create a method in task that will return all of the tasks that are due. So very, very simple. Now, when writing tests in the spec style, I like to organize, I like to structure tests in this manner. So I start with describing the method that I will be testing. So in this case, I'll be testing a due class method. Beneath it, I'll be listing down all of the contexts that are applicable to that due method. And finally, given those contexts, I will be testing certain expectations or certain assertions. So this is the basic structure. Now, aside from these main three elements, I also sometimes group contexts when they are concerned with different aspects or concerns. So you would have this optional grouping here. So we'll cover all of this in our demo. Okay. So again, we're going to create a .due method that would return all of the due tasks that are due. I like to organize tests by method like this. There are some who argue that this is an anti-pattern and that it's preferable to write tests with respect to the class itself. So for example, instead of testing if task.due will do something, you may end up with a test suite that says wherein your task can be due or task can be not due and so on. All of them related to the task class itself. In my experience, though, I find that this makes it a bit easier to organize your tests. even if it does it ties your tests with how your methods are currently defined. So for the purpose of this demo, we'll go with this structure. Now, if we have a do method, the next thing we consider is what are the contexts that are applicable to that method. Typically, if we have a method that operates on a collection of objects, in this case, tasks, we want to test the basic scenarios that we want to consider are those that are concerned with how many tasks currently exist. So we would set up a context to test if when there is no task at all and when there is a task. So the describe keyword is taken from Minitest. This context is not part of Minitest. It is provided by the Minitest spec Rails gem that I showed earlier. Also, if we try to run this now, we'll encounter an error. And basically what's happening here, okay, I missed the the double quote there. We'll get an error saying that there's a wrong number of arguments. Basically, we just need to provide a block for each context in order for the test to pass. All right. So now the test is passing. Okay. So we've covered two basic scenarios. There's either a task either exists or it doesn't. Let's try drilling through the first context. So if there is no task, then we can expect that task.do will be empty. So that is the assertion that I'll write here. Notice that the it keyword here is referring to the subject that I'm testing. And I'm explicitly writing the spec with regard connected to this do method. So what I'm saying is that, okay, the it here refers to task.do, not the task class or the instance of class. Okay. Now that we've written a spec and describe what we expect task.do to return, the next step is to translate the spec that we have into actual test code. In this case, we're expecting that task.do will be empty. So in Minitest, we'll just say that assert, I think we can do assert empty task.do. Okay. And if we run the test right now, okay, it will tell us what to work on next. It's saying that there's no do method in the class task. So let's bring up the task class and define a do class method. And now the error is we're expecting object to respond to empty, but now our return value is nil. So in this case, this is returning nil, and we need it to return an object that responds to empty. For now, we'll just set it to an empty class, an empty array. Okay. So we've at this point we've defined a single spec and structured our test with the structure. We have a subject, the context that applies to that subject, and then our expectation when that context is met. Okay, let's try and move on to the next context. Okay, when there is a task. So the question now is, if there is a task, when can we know if it is due? There will be three scenarios. All of them are concerned with comparing the due at timestamp with respect to the current time. So the first one is when the task due at is before the current time, and when it is on the current time or at the current time, and when it is after the current time. Let's tackle the first context. And before we do that, we provide blocks for each of the contexts so that the test will pass. Okay, so let's try tackling this first one. When the task due at is before the current time. So right now, our time is 6:30 p.m. So if a task was due at 6 o'clock, 6 p.m., then we can expect that task to be returned by task.due. So we say that our task.due would return the task, or to be more precise, would include the task. Now, the way I write tests, I like to write them from the way that I implement the tests. I like to implement them from the bottom up. So I start with in this case, I start with the assertion or our expectation. And I translate this part of the spec into actual test code. So we're expecting that task.due would include our task. Notice that task is not yet defined anywhere in our test. This is okay. Let's implement it like this. So this task is not yet implemented. We'll tackle that in a bit. But for now, let's just move up to the context above it. So we're saying, and our context is when the task due at is before the current time. So I try to implement this spec as close to the spec as possible. If we are going to use setup, then what we want is a task.due at is before the current time. So we would have a current time variable, and we can just subtract a time from it. So this defines due at with respect to our current time. Finally, at the top, we say that when there is a task. So this is the part wherein we define the task itself. Okay. Before we continue, we should take note that after we've created the task here and we've changed the duat here, we'll still need to save the task before we do the assertion. Otherwise, the duat won't change. So let me see if this works right now. Okay. Okay, undefined method for minus sign because we didn't define current time. Okay. Now we need to define current time. And we can see that in our three contexts, current time is only being used within this context. So what I'll do is I'll define current time only within this block. That's set to current time for now. Notice that I chose to keep that current time definition as close as possible to where it is used. I didn't decide to define this, for example, at the very top. This way, it's easier for me to find the definition of a variable where it is being used. Okay, so if I run this again, okay, we're getting an error saying that we're expecting this. Basically, this is failing. Task due is not returning. It's not including the task. So now, if we go back to our task class and update task due, the most minimal way that we can get task due to include that task is to just return all of the tasks. So now our test passes. Task.all is passing this test as well as the one above, wherein we have we're assuming that task all is empty. In this case, we could make sure that that this condition is actually being met by our test suite when it runs. Sometimes because of the way we set up our test suite, we may create some initial objects before we at the very start of each test. So just to ensure that doesn't happen, we can assert that that our task all is actually empty. So this condition implements the spec when there is no task. Okay. Again, if we run, task passes. All right. Now, before we continue, I'd like to do some refactorings first. So one thing I like is I try to when I'm writing test, I try to avoid setting variables against values that are not deterministic. So for example, here, I'm setting current time to the current actual time of the test suite. It's usually better to just set your time values to a fixed time point. So for example, we can set this to today, and then we use Rails freeze time. First we need to travel to that current time and then we freeze it. That way, when we run this test, it will always be with respect to this time. This is a good strategy if you're testing against, for example, if your code is if in your code you're converting the current time, to example, to date. So you may want to fix the time in your test so that it is consistent. If you do want to test the time against different time zones, then you can choose to set the time to multiple time values with respect to the different time zones. But doing this way, we make the test more deterministic and less flaky. All right, so the test is still passing. The next thing I'd like to show is that in this test, we manipulate the task object 2 times. First, when we instantiate it, and then when we change its due at 2 to be based on the current time. This is okay, but there are some instances wherein this makes the test code a little bit harder to set up because you're manipulating it after it has been created. Also, if your task object has, for example, callbacks that are called when the task is updated, then that may affect your tests in an unexpected way. So for me, ideally, it would be nice to be able to create that, to set up the task on instantiation, which means when it is created here. And one way to do that is to use let variables. So what we'd have is we'll define task using a let variable like this. So let's try it. So we would have a block for let like this, wherein we create a task like so. This block is essentially a memoized method. It is equivalent to doing something like this. It just provides a little bit of a syntactic sugar so that you don't have to write it this way. Minitest provides this let and this API for let, although it frowns on its use. It's let is more popular with RSpec. Okay, so we've defined a method for task, but it's not called immediately. So we still need to call it within our test suite. So here, instead of so here we need to call task in order to create this task instance. And at this point, we can call task like this. I think it should pass. Oh, it didn't pass. Expected relation to include, okay, it's returning. Okay, nil. So I didn't update this variable here. So, okay, now the test passes. Let's do the same for current time. And we call the current time method instead of the instance variable. In this case, we don't need to, since current time is being called here, it will be set to this time. Oh, sorry. test still passing. And finally, we're at the point wherein we can avoid having to mutate the task after it has been instantiated. What we'll do is we'll create another variable for duat that is set to current time minus 1R. And then in our task above, we will set duat to this value. So that's the benefit and both the benefit and disadvantage of let variables. You can allow your context to override the value of duat. We could, for example, set a default value for duat here at the top and say, let's just set it to current time. But even if we do this here, this definition of duat in the context will override that. So it's okay to provide this default value. At the same time, it's also okay not to include. It's also okay to expect that our context will be implementing that duat method. So let's try and run this again. Okay, test is still passing. Okay, so let's continue with implementing the other context. Here, the next one is we test if duat is at the current time. So similar to this, we just define duat with respect to the current time. We're expecting them to be equal. And if this is the case, then, for example, right now it's 6:45. If the task due at is 6:45 p.m., then we can expect that task to be due. So we're expecting task due to return the task as well. Okay. If we run the tests, again, it's all passing at the moment because we're returning task.all. But if we go to the last context, when the task due is after the current time, so we define due at after the current time. In this case, we can expect task due to not include the task. So for example, if the task was due at 8 p.m., then it is still not it is still not due. So assert includes assert not includes, I think. Okay, so now we're getting a failure that the relation is not expected relation. It's hard to read. But yeah, on line 55, this one is failing. So we need to implement the actual filtering. So we check if the due at is less than or equal to some current time, wherein we set that current time to time.current. All right, so all of our tests are passing now. All right, so that covers task, but I actually missed a particular scenario here. If we go back to the schema, a task due at is not does not require, is actually not required, right? So it's possible that due at is actually nil. So that's something we missed. In all of this context, duat is set to a certain value, so that all of these are covered by the scenario we're in when the task duat has a value. Oops, sorry. Mhm. Now we need to implement the opposite of this scenario, wherein it doesn't have a value. Again, we translate this context based on how the spec is described. So we set duat to nil. And in this case, if a task doesn't have a duat, then it can't be due. So we can say that it does not include the task. Let's try this right now. See if that works. Okay, we got an error. Okay, this one. And there's a typo there. Duat undefined method. Okay, I didn't do this right. One more error. Okay. That is interesting. I didn't expect it to pass. Assert. I'm guessing it's because. I guess the condition passes even if duat is nil. All right. So that covers the scenario when there is a task and when there is no task. The question in my mind is, do we need another scenario when to check if there are multiple tasks? So in this case, I think that this scenario already covers this context. When we say when there is a task, it's possible that our collection of tasks is only has a single task, or it can have multiple tasks. And we can, if we're implementing our due method using Rails query methods, we can expect it to operate on collections, collection of tasks. How do I describe it? Yeah, we can make that assumption that it will work on a collection of tasks. So in this case, I would no longer bother to create another scenario just to test on the scenario wherein you have multiple tasks. It's a bit superfluous at this point. Okay. So we've covered testing how task.do works. Now, let's say that we've been given a new requirement that we want the due method to return tasks in ascending order by duat. The question is, where do we implement, where do we add the tests for that particular concern? So We could, well, if we think about sorting, sorting makes sense only if we have multiple tasks. It doesn't make sense if there's no task at all, and doesn't make sense if there's a, it's not particularly useful to have tests if you have only a single task. So we may decide, okay, we want to test sorting if there are multiple tasks. So perhaps we need to bring back that context wherein we have multiple tasks. And here we test that the Jew is task.Jew is sorted, something like this. So what I'd like to point here is that although this covers three scenarios that are related to one another, the assertions inside them are concerned with different concerns about that task.Jew. The first two contexts are concerned with filtering tasks, which task will be returned by task.Jew, while this multiple scenario is concerned with sorting those tasks. So it's not as elegant as I would like it to be. Another option might be to extend this when there is a task scenario. So here we have we have defined a certain task, and now we may decide, okay, let's handle the scenario when there is another task. And here we can say that we can test we can test how sorting works when we have our main task and we have the other task. Again, my concern, my issue here is that these contexts are concerned with filtering, while this one is concerned with sorting. At the same time, this sorting context is deep within this context. So it's a bit hard to see where it is if you're looking for it. So what I do in this, if you have a method that you want to test for different kinds of concerns, is I simply group those concerns. So here I would have another context for that is concerned with filtering. And I move these two the set of tests here. And below it, I have another block that is concerned with sorting. So by doing it this way, the tasks that I have defined here are not do not infect the the setup that I'm going to do here. So let's try and see how we can test sorting. Typically, it is common to have something like it is sort to just test that the turn value of this method is sorted, and within your block you have, maybe you create several tasks and with different duats, and then when you call task.Jew, you ensure that all of those tasks are in the right order. That's okay. But let's try to break it down in such a way that we only create the least amount of instant methods, least amount of instant objects that we need to in order to prove that sorting works. Going back to the idea I had earlier, we can have We can start with having with one task when there is a task. And comparing it with another task. And then based on their due at, so in order to make this easier, let's just name those tasks, task A and task B. So in this third context, we check if task A, or let me change it with when task B due at is before task A due at. Oops, sorry. So I chose to write it like this, wherein I define task B due at with respect to task A because, well, let's do the assertion first. So if task B due at is before task A, then we can, and then task that due should return tasks in this order. Sorry, task B is before task A, so it's the opposite. All right. Let's just implement it for now before we consider the other two contexts. There's another context for when it is the same and when it is after. Okay. So going back here, we can expect that task.due would be equal to, we have a task A, a task B, followed by task A. This assertion assumes that in our collection, within this particular test, only two tasks have been created. So there's an implicit assumption that when we started this test, our task table doesn't have any tasks at all. We can reinforce that assumption by testing that precondition beforehand. So we can assert, again, at the very top, we can assert that at the start of this test, task.all was empty. That way, because of this condition, we're more certain that this is always true. Okay. Okay. Now that we've implemented this assertion, let's implement each context from the bottom up. So here, we're saying that task B due at is before task A. So we'll need, if we're going to use let variables here, then we need variables for the due at of task B and set it to the value of task A. In this case, however, we don't need a variable for task A due at because we're not going to, we can define it when we create the task here. So here we set task B to be before task A due at. And in this context, we implement that task B. That it's due at to the value of task B here. And make sure that this task B is created within this context. In RSpec, there's a let exclamation point that is that is a variant of let that immediately instantiates task B. But in Minitest, this isn't provided. So we'll have to do it like this. Finally, we can do the same thing for task A. We create task A like this. And we make sure that due at is set to a specific time. We could, if, for example, if let's say your task factory already sets due at. So the question is, do we need to, if we know that a factory already sets the due at variable, do we still need to set it here? I think it's better to set it just so that we avoid making assumptions about our factories within our tests. We don't know if later on, if that due at, even if it's set right now in the factory, if it will be set to nil later on. So it's best to be explicit about it. So, and by being explicit about it, so let's say let's set it to time.new. Let's set it to this current time. It's also good to express your specs as close to how you're implementing it. So when we said earlier, when there is a task, what we actually meant was that there's a task with the due at value. Again, it's possible that the task might not have a due at value. And the same with task B. Both of them are expected to have due at values. So will this test pass at this point? Okay, so it does not. Yeah, it's not sorting task B and task by due at. In order to make this pass, we just order our tasks by due at here. And if we run again, okay, now it passes. So before we continue, there's a question of, okay, what if our tasks don't actually have a due at value? What if one of them is nil? If that is the case, then we can expect a task with a nil due at to be excluded from the results of task due. That's something that we've tested here. When task due is nil, it would not include the task. So as a result, we don't need to be concerned about the scenario wherein either task A or task B has a nil due at. We can expect both of them to have values for that field. All right. Okay, so let's implement the last two contexts. Now, if we look at the second one, if they have the same due at, then it's actually, we won't know exactly which one of them will be appear first because they have the same value. In that case, we can simply choose not to implement this context because it's not something that's useful to test. However, for the last one, we can expect that, okay, if task B due at is after task A, we implement it by adding time to task A due at. Then we expect that tasks, plural, are return tasks in this order. In this order. All right. And okay, so the test still passed. I think the last thing I wanted to mention was that when I was writing this context, I intentionally defined task B duat with respect to task A. The reason for that is you might think, okay, wouldn't it have been more easier to read if we said task A is before duat, if we organized the test in this way? If we went with that route, then we will need to implement that. We will basically swap our task B and task A like this. And it would be a bit, we would have the situation wherein, okay, your task B is the one that you define first, or that your task B has to be created first before you create task A. Given that given that we have this nesting wherein task A is the one that is outer than task B, and we're expecting task A to be created before task B, it's better to have task B to be defined with respect to task A. So that's why I chose this order for the specs. So to summarize, I've shown how I structure tests. Again, I group them by method. The subject of each test is a method in the class. I define what are the contexts concerning that method. I try to make the context, I try to make related contexts or group within their particular concern. And I ensure that when I'm implementing all of this, I try to stay close I try to make the abstract spec as close to its concrete implementation. I guess last thing I like to add is that, okay, having this multiple describes here allow me to separate the fixtures for each concern. So here, for example, here I have variables for task, for current time, but those are not relevant to sorting. So these ones have variables for task A and task B. They don't mix, making it easier to ensure that, okay, if I make a change within this describe or within this concern, it won't affect other concerns within the test. Okay, so yeah, that covers my demo. Do you have any questions? Sorry, sorry, I asked for questions only at the very end. I okay.
When you do your system specs, I mean, this is getting into a little
System
bit.
specs. Yeah, like
Yeah.
system specs. Yeah.
How do you run that in production, like in CI/CD?
Okay. So question is, how do we run system specs in production?
Yeah, what's your preferred or like what do you find works well for you?
Okay. Okay. First off, I guess I guess I'll try to I'll try to connect your question with regard to system tests with with how I structured unit tests here. Uh, I'll try to answer it that way. Okay, so first off, I I generally prefer to have more. I prefer to cover tests using unit tests as much as possible, and use system tests only to cover the main scenarios or your core scenarios, especially the ones that are critical. I think system specs work best with if you're testing flow. If you need to test jumping from one page to another, like say a checkout. So system tests work well in that scenario because you can't test that well with just controller tests. Um, with regard to with regard to structuring tests, the system tests, what you would notice is that you'll have a lot more setup compared to unit test because you're setting up, for example, in order to test if a checkout succeeds, you need to set up a user, you need to set up an account. So there you'll need to set up several objects, and that can make your, if you're trying to be as pure as the one as I try to do here, it could result in a very long breakdown of context. So when it comes to system tests, you try to, in order to be more practical, you end up generalizing your context. They're not as specific as what we have here. For example, earlier I had rather than going through each of these scenarios, you may just decide, okay, and let's say this was a system test and you wanted to test sorting in a certain page. So it's fair to just test if it is if that if the if the tasks in that page are sorted, or if we're going to use this subject description, this format, we can say your page shows tasks or in sorted by duet, for example. So it's in order to, you end up doing with system tests, you end up grouping the way you set up your instances, your objects. At the same time, you end up doing several assertions within each block. So it's fair to do that within system tests. What else? Yeah.
Okay, new question. When because you've been doing Ruby for many years. When did you start doing TDD? How many years into your thing? And if there was like a beginner developer, what would you recommend them when they're starting to learn?
in TDD. Yeah, I was when I was making this demo, when I was practicing this demo, I was actually curious to see how many when did when did TDD became when did TDD become very popular, especially with talks. I didn't actually that's something I think I'll do a search on that later today. I'll try to Google when it was most popular, especially in Ruby conferences. But with TDD, I think yeah, at the at the very start when I mean even before I started with Rails, I was working with Java, and I've already heard about the benefits of having tests. I remember that I've started experimenting with writing tests even with Java code, although I don't think I've been doing it in the test-driven style. When I started learning Ruby and Rails, I think um, I guess that I've part of what I've read before was that they've already incorporated how to write tests, how to implement Rails features in test-driven fashion. So I guess I've already learned TDD at the start of my Rails development. Um, yeah, it's hard. I don't have any specific resource right now on how to learn TDD. Uh, there was a one particular talk that I watched before. I still have to find it, wherein the presenter explained, okay, when is it when does it make sense to use mocks uh, with he tried to handle the issue wherein, okay, if you have, for example, another method, let's say we have a method, say recommended, wherein recommended returns
I think probably don't need to get into the code right now. We might not have too much time left.
yeah,
But
yeah.
what would be your advice to like someone who's still learning how to code in terms of
Mhm.
like how to learn tests and how to like how big of a deal is
Okay,
testing when you're
right.
learning how to code?
Okay. Yeah, when you're learning how to code, it's hard to learn testing and learning how to code, writing tests and learning how to code at the same time. So I'd recommend if they're just starting with Ruby, for example, that they just test it in the manual fashion, right? You're running you have your console open, and you have your test and sorry, your application code. You make a small change to your application code and you test it manually, either by looking at, for example, in Rails, looking at the web page, or by testing it in the console if you're more from if you have already have experience working with the Rails console. And then when you gain more confidence with writing Rails, that's the time when you start automating your manual tests. And that's the time when you try to, okay, I at least I'm no and if you already have a feature that you already built before, then that's a good time to start implementing similar features in test driven fashion, because you already have an idea of what is the next step. uh, you can you can write the test and do each step in tandem. So that's my advice.
Very nice. Well, thank you, George. You give a round of applause.
Thank you very much.
Everybody online. Awesome.